So let's start with today's session. We are going to see insert function from the topic circular queue. We are going to understand how programmatically the function is written, line by line execution of the code. So for that, already I have covered the concept of queue, basic concepts of circular queue. Please go through that so that understanding the function becomes much more easier. Circular queue is what we are going to see, and in circular queue the concept that we are seeing is insertion, that is enqueue. So let's start with the topic. The very first line that you see is void CQ. CQ stands for circular queue. You can give the name of the function insert, and I'm passing the data. Okay, I'm passing the parameter. After that, let's try to understand our if condition. Now, this if condition over here is talking about checking whether my queue is full. Why do we check queue is full? We have already seen the concept in our stack, in our queue, and now in our circular queue also. That whenever we are trying to insert an element, we have to check whether there is space inside my particular data structure. If there is no space, there is no point of inserting. So for that reason, I need to check the concept of is full. How am I going to check is full condition? I have said front equal to rare plus 1 mod of max. And let's try to understand the concept of circular queue. I hope you already remember the topic that was discussed in basics of circular queue. This is how your circular queue would look like, and this is how the representation of elements would be structurally seen. Okay, the numbering starts from 0, 1, 2, 3, 4, right? So total max size is of 5 elements. Okay, and these are my elements. Visually you can see it is full, right? So I'm going to check my front. So here, as and when you start working on your queue, your front and your rear are -1 when your queue is empty. When you want to insert your elements, your front and rear would point to 0. That is the first location. And after that, for insertion, your rear will go on incrementing. Now let's increment the rear. The first element is put, rear would be incremented, second element is put, rear incremented, third element put. So till fourth, my rear would be pointing here. And now my front always points to the first element that is there in my queue, in my circular queue as well. So front will be pointing to 0 only. Front will work only when I want to delete the elements. Now my rear has reached its maximum size, right? 4. Is there a space here in my queue? No, right? So for me to check this, I have this condition. Now let's see how this is checked. Front equal to, what is the value of my front? The value of my front is 0. Equal to, comparison. My front is 0. Is my front equal to, what should be my condition? When my rear is here, I've already inserted the element. Now when I want to insert it, my rear will increment. And once my rear increments, is there space here? That is what I want to check. So for that, what am I checking? Are my front and rear at the same location? Okay. So now front and rear at the same location. This is a circular queue. How will I check it? Front equal to. Rear plus 1. This concept we had seen in basics of circular queue. Rear plus 1 mod of max size. So I need to check it. Rear is what for now? My rear is 4 plus 1 mod of maximum size. My maximum size is 5. Do the calculation. 4 plus 1 is 5 mod of 5, that is 0. So my front value and my rear value are same, and if they are same, that means my queue is full. To check is it full, I need to check whether my front and rear are at the same position. So if front equal to -1, bring it to 0. So we know this. If our front and rear are at -1, right, get it to 0. After that, rear equal to rear plus 1. Now this line is very important. What do you do in this line? You increment your rear. Increment your rear. Okay, so you have to remember, for circular queue, to increment your rare, this is the formula. That is rare equal to rare plus 1 mod of max size. Okay, that will increment. So suppose my queue is empty. Okay, the very first thing I do is I check my condition. Is it full? It is not full, it is empty. Okay, the next condition I check is what? Next condition I check is whether my front is -1. In this case, yes, it is -1 because it is empty. So what I'm supposed to do? I'm supposed to point my front at 0. Okay, front which was -1, it will point to 0. Second thing I have to do is I have to increment my rare, but rare I'll not do r plus plus. Here I have to use this line to increment it. Let's see how this works. Rare equal to, understand this, here it is front equal to, you're checking front value with the rare value. Here you are assigning the value. So rare equal to rare plus 1 mod of max size. Let's try to execute this formula and see. What is the value of rare for now? Rare is -1. So -1 plus 1 -1 mod of max size, that is 5. That is 0 mod of 5. Okay, the answer would be what? 0. Okay, so my rare is pointing here. I'll insert the element. So this line is basically incrementing your rare. Once I increment, now what will I do? I'll insert my value, the data that was taken in. So I'll insert that at my rare position. Q of rare. Q is the name of my queue. Q of rare. Where is my rare pointing? Here. I'll insert the data that was sent from here. Suppose it was 10. Okay. Let's try to understand this again. I want to insert the element. For inserting the element, my rare works, right? Front is for deletion, rare is for insertion. Again, it will come inside, it will accept the data from the user, come inside, it will check is full condition, because if it is full, I'll not be able to insert. In this case, it is not full, right? How it is not full, even that you can check. My front is what? Front is 0. Front is 0. Okay, for now. Front equal to rare plus 1. What is my rare? 0 plus 1 mod of max size, mod of 5. 0 equal to 0 plus 1 is 1 mod of 5. 0 equal to 1. Is it equal to? No. So this condition is false. That means there is space. After that, if front equal to -1, this condition I have to check. No, my front is not -1. So I move to the next part. Rare equal to rare plus 1 mod of max size. This line is incrementing your rare. Incrementing rare. So what I'm going to do, rare plus 1 mod of max size. Let's try to do this calculation again. What is my rare now? It is 0. Earlier it was -1, right? Now it is 0 plus 1 mod of 5. 0 plus 1 is what? 1 mod of 5. That is equal to 1. So your rare now is what? 1. So your rare which was pointing here will point here. Once the rare is incremented, I'll put the data in my rare. 20. Clear? In your queue concept, you do R++ for inserting of elements. For inserting elements, you do R++. But in circular queue, you do what? Rare plus 1 mod of max size. Okay, this is very important. Remember that. That is what you do over here. Clear? Try to go back and check the video for basics of circular queue. That will help you to understand the concept well. And once your concept is well, function execution or understanding of the function would be much more easier.